Hi everyone, welcome to another video by Maths with Sarah. So this question I actually posted yesterday on Instagram and Twitter. So if any of you had followed me on there, you may have had a chance to have a look at this already. And today I'm going to be posting the answer here. So what we've got is a triangle question. We've got two triangles, triangle ABC and triangle ADC. We've been given various angles, a length, and we've also been told the area of one of the triangles. And we've been asked to work out the length of one of the other sides, AB. Now, if you haven't already had a look at this question, I encourage you to pause the video now, have a look at it, have a think about what method you would use or how you would go about doing this. If you can't do it, then don't worry, I will go through it in a minute. I will say that this question is a particularly tough question. So it comes from paper 3. It's around the back of the paper right towards the end. So it's question 17. It's a calculator paper and you will not be able to do this without a calculator. So as I said before, it is a really tough question, but I'll talk you through it step by step. So as this is sort of towards the later end of the paper 3 question, there are a few assumptions that I make that you are comfortable using your calculator to do sine, cosine, tan, and also that you're comfortable using it and not using the answer button, so you don't have to round the answer throughout. That's the method that I've been using. So if you have rounded partway through, then you may find that you get a slightly different answer. But I've checked in the mark scheme, and as long as you've made it clear what you've rounded to, then it doesn't cause you any problems in terms of getting the answer correct. I'm assuming that you're quite happy rearranging equations, which I would think that if you're thinking about tackling this question, you're probably looking at aiming towards sort of grade 7, 8, 9. So you should be comfortable with those techniques. But everything that's more challenging than that, I will talk you through. So I encourage you to pause the video now, if you haven't already, have a think about what method you use and pop back and I will go through this question in a few seconds. Okay, so the first thing that you, so we've got these two triangles. We've been told various angles, and one of the first things that should really jump out at you about this question is that you have not got any right angles. So the majority of the questions in this question would be far nearer the front of the paper if it did have right angles. So it's a particularly tough question purely because there are no right angles in these triangles. And that means that whereas normally you would be able to solve this using straightforward Pythagoras or straightforward trigonometry, with this one, we're going to have to use more advanced trigonometry and some of the different area, cosine, sine rules in order to tackle this question because it doesn't have any right angles in the triangle. So we've been given two of the angles in triangle ABC, and we've been asked to find this side length, which I've called X for now. And we've been told ADC, this triangle here, and we've been given one of the lengths as 11 meters, and we've been given one of the angles, and we've also been told the area of this triangle is 56 meters squared. So how would you go about tackling this question? So I think this is it. Regardless of whether or not you can get to the answer, one thing that I think is really important is that you think about, this is essentially a problem. You've got to solve this problem. How do you go about the steps? So it doesn't matter really what the question is. It's as much as anything about thinking about how you would solve this problem, how you would answer this question, what methods you would use, what steps you would use. So if I was presented with this question, I think probably one of the first things I would do potentially to find out this angle, because that's fairly straightforward. However, that's not really going to help us to find any of the side lengths. So we know we need to find out this side length, but we're going to really struggle to do that if we haven't got any other side lengths at all. So the way to tackle this is to think about what we do know. So we know that we don't have any information about this triangle, or we don't have enough information to find out what this side length is that we need to. But that's pretty much why we've been given the other triangle. So we can use this other triangle we've obviously got one side that's in common. And so we can maybe think about working out what this side length is and then going from there. So I've already said that we're going to be using some of the more advanced techniques. We've been given the area, so potentially we'll have to use the area rule. And we've also potentially going to be using the cosine and sine rules. Now, I'm sure you're all familiar with these rules, but if we're just thinking about which ones we might have to use. So for the sine rule, we need an angle that's opposite a side. So for example, we could use this angle and this side here, but unfortunately we don't know that one. Or we've got this side here and we would need this angle, but again, we haven't got that. So we can't use the sine rule. So the second rule is the cosine rule. And for that, we either need all three side lengths, which obviously we don't have, we're a little bit short on side lengths in this question, or alternatively you need like side angle side, kind of all linked next to each other. And again, we haven't got that. So we're left with the area rule. Well, this one actually seems like logically like it might work. So we've been given the area of this triangle ABC, and we've been given a side length and an angle. So if I write down the area rule, we know that the area is half, so normally it will be half base times height. Obviously in this case, it sort of is half one side length times another side length, and then sine of a third angle. So for example, if we think about how we label up this triangle, we have this one will be kind of big C, little c, this one will be big B, little b, little a, and then this angle here will be big A. And from that, we can use this to work out the remaining side lengths. That will tell us, if we think about what we've been given here, we know that we've got this angle, so this will be sine of C, it will be a sine of 105. We've got one side length, and then we've got another side length that we can find out using this equation. So if we go through it, we're obviously going to have to rearrange it, but we can do that later on. So we've got 56 meters squared to the area. Then keep the half. We're trying to work out what A is, so we can leave A as it is for now. We've obviously got B is 11, and then we'll do sine of 105 times that. Okay, so if we then kind of key into our calculator as much of this as we can, and we're going to end up with 56 equals 5.313 times A. And now hopefully you realise if we divide both sides by 5.31a, we're going to end up with A equals 10.54. And this is again where I'm not going to round, so I've kept this I've kept this number in my calculator so that I don't end up with any rounding errors. So I can keep this answer all the way through. So let's rub out these letters that I've drawn on, because we don't need them anymore. We know that this side length here is 10.54. Okay, so let's have a think about where we are now. So we've now got a side length, ideally, not the one that we wanted. We'd ideally want this one here, and the central one. But we have now got two side lengths and an angle. And hopefully you remember what I said at the start. So if we want to use the cosine rule, we need to have either side, angle, side, or three sides. Well, brilliant. We've now got two sides and an angle in between. So if I just write down the cosine rule, this is probably the longest rule. It starts off very similar to Pythagoras, actually. So we've got a squared equals b squared plus c squared, but then we minus 2b c cos a. Okay, so when we think about how we're going to label up this triangle, we know that we want to find out what A is. So we'll call this side length here A. That then means, as we know, this one needs to be big A for the angle. And then it doesn't matter which way around we label these sides. So we'll call this one B and this one C, just for the sake of argument. So now if we pop the numbers that we know into this, we don't have to rearrange this one, we can just use it as it is. So we're going to end up with A squared equals 11 squared plus 10.54 squared minus, I'm going to pop this all in brackets just so that it kind of keeps it separate from the rest of it, don't end up getting confused, which is one of the biggest things with these. 10.54 times by cos of 105. Okay, I would advise you try and pop all of this into your calculator in one go, if you can, just because otherwise sometimes the calculator does some little funny bits where it sort of forgets about brackets and things. So sometimes it can be easier to just pop the whole thing in one go. Remember, you can use your answer button, assuming that you've left it up on your calculator, you can use your answer button for putting in both of these in the previous calculation that we did. And if you do that, you should end up with A squared equals 292.133. When I first did this question, I thought, that's huge. What have I done wrong? Like, how can this be 292? And then I realised I'd forgotten the square root. So if we square root at this stage, you can end up with 17.09. And again, this is obviously in meters. Oh, I've just realised I've left the A squared. It should just be A because we've now square rooted that to find out what A is. So we figured out A, and we know that this is 17.09. Brilliant. Right. Okay, so we've now found out one side length of this triangle here. So we can now ask ourselves a couple of questions. So do we use the cosine rule again? Well, we said for a cosine rule, we need side angle side, and we don't have that. We don't really have any combination of that. So that is going to be tricky, or we need all three sides. Again, we haven't got that at all. So the alternative is that we're going to have to use the sine rule. So for the sine rule, we need an opposite angle and length, which we do have in this question, and we then need another angle, which is exactly what we've got in this question. So we've got an angle opposite a side, and then we want to calculate another side that's opposite another angle that we've got. So perfect, let's use the sine rule. And because we're trying to figure out a side length, we'll put the side length on top. So always put the one that you're trying to calculate on the top, because it just makes the math slightly easier. So again, we'll call this one A, this one big A, and then we'll have big B and little b. So hopefully you remember the sine rule is probably the easiest one to remember. There's not really much to it. So we've got A over sine A equals B over sine B. And I'm sure you remember, but you can also use this, it's exactly the same because it's just a ratio. You can actually use it the other way up as well. So you could have sine A over A equals sine B over B. And you can use that if you're trying to find out. That's slightly easier to use that version if you're trying to find out an angle. So let's substitute in what we know. So we've got x is the side length. That's the one that we don't know. We're trying to find out. We're going to divide that by sine of 48. And we're then going to substitute in these. So we know that B we've said is 17.09. Although you might want to use the answer button on your calculator to put this in more directly without the rounding errors. And then we'll put that over sine of 118. So hopefully now you realise that if we want to find out what x is, we're going to do times both sides by sine 48. So we'll end up with sine of 48 times by 17.09 divided by sine 118. And if you pop all of this into your calculator, just remember to use brackets for this so that you don't end up with sine of 48 times 7. You know, you just want sine of 48 exactly. If you pop all that in, then you can end up with 14.3856. And it's requested that we round this now to 1 decimal place, in which case we're going to end up with 14.4 meters. Okay. And that is this side length that we've been looking for. We've had to do 3 quite complicated calculations to get there. We have now found that side length. So hopefully you were able to follow that all the way through. I appreciate that it was a really challenging question, but hopefully this has simplified it somewhat. I think the key things, so the key really challenging bits I think most people will find most difficult are realizing what rules you need to know, and realizing that you've got to start by working out the side lengths and the angles of this triangle before you can get anywhere near finding out what x is. And I think that's what makes it such a complicated question, is you've got to do quite a lot of other calculus, where you've got to do 3 complicated calculations before you get anywhere near finding out what x is. So I think it's really important to realise that. I mean, I have given you the clue here by telling you the area of the triangle, and that quite often can be a good place to start. So please subscribe to my channel. I will be posting videos most days at the moment. So please subscribe to my channel to get the first look at any new videos. If you've got any particular requests, just drop me a message. And hopefully I'll see you all when I do the next video. Thank you for watching. Bye.